Welcome to section 2.1, the data lifecycle, from collection to deletion. In artificial intelligence, data isn't just an input, it's the foundation that determines the quality, fairness, and security of every system we build. Mastering this lifecycle is critical because mishandling data isn't just a technical error, it's a business risk, a legal liability, and a threat to trust. Whether you're an engineer, a manager, or a security professional, understanding the data lifecycle will prepare you to make responsible decisions in the real world. Here are the objectives for this lesson, and by the end, you will be able to define the 7 stages of the AI data lifecycle, identify the roles and responsibilities of key stakeholders, explain the risks and safeguards at each stage of the lifecycle, connect these lifecycle stages to professional best practices and regulatory requirements, and finally, evaluate how lifecycle management impacts trust, compliance, and the overall success of AI systems. All right, so what is the data lifecycle? Think of the data lifecycle as a relay race. Data is collected, stored, labeled, and processed, passed from one team to another until it feels training, gets archived, or is securely deleted. At each handoff, risks appear: privacy violations, bias breaches, or even accidental misuse. The solution is governance, defined roles, clear responsibilities, and compliance safeguards. On the exam, you may be asked to match a risk to the correct lifecycle stage or identify which role is responsible for a safeguard. In practice, understanding this lifecycle prevents mistakes that can cost millions of dollars or destroy public trust. So, collection is the first stage where raw data enters the system. This may come from IoT sensors, customer transactions, surveys, or third party sources. The key risk here is legality and fairness. Was consent obtained? Is the data set representative, or does it exclude key populations? The data owner defines why the data is being collected and ensures business alignment. The privacy officer ensures proper consent and compliance with laws like GDPR or HIPAA. On the exam, if you see a scenario where data is gathered without user permission, you should immediately connect it to the collection stage. After collection, data must be securely stored. This could mean databases, cloud repositories, or enterprise data lakes. Risks here are well known: misconfigured cloud buckets, unencrypted storage, or unauthorized access. The data steward maintains the integrity, organization, and accessibility of stored data. The privacy officer ensures encryption, access controls, and compliance with retention policies. In real-world breaches, most failures happen here. Weak storage practices are the culprit. On the exam, if the question references data at rest and encryption, you're dealing with the storage stage. Labeling transforms raw data into usable training material. For supervised learning, every sample must be tagged. For example, labeling medical scans as benign or malignant. The annotator performs the labeling, often supported by annotation tools. The data steward enforces labeling guidelines and audits quality. Risks include human inconsistency and bias. If annotators carry assumptions into their work, the AI model inherits those same biases. On the exam, if you see a question about supervised learning datasets or annotation bias, the correct lifecycle stage is labeling. Pre-processing prepares raw or labeled data for modeling. This may involve cleaning missing values, normalizing ranges, or extracting features. The machine learning engineer leads this stage, ensuring data is ready for algorithms. The data steward monitors quality and prevents accidental distortions. Risks include information loss from overcleaning, amplification of existing bias, or data leakage if pre-processing introduces future information into training. On the exam, if you see normalization, scaling, or cleaning missing values, recognize that you're in pre-processing. Training is the most visible stage. Here, the prepared dataset is used to optimize model weights. The machine learning engineer runs training jobs, while the data owner ensures data is aligned with business purposes. Risks include overfitting, where a model memorizes instead of generalizing, and underfitting, where the model fails to capture patterns. Data leakage can also occur, leading to artificially high accuracy. In both the exam and real practice, understanding these risks is essential for evaluating AI performance. Archival means keeping data long term, often for legal, regulatory, or auditing purposes. The data steward manages where and how data is stored, often in cold storage systems. The privacy officer ensures retention does not exceed legal limits. Risks include keeping data longer than allowed, exposing outdated data to breaches, or spending excessively on storage. On the exam, if you see the term cold storage or data retention policy, the lifecycle stage is archival. The final stage is deletion. Regulations such as GDPR's right to be forgotten requires secure erasure of personal data when no longer needed. Deletion must ensure data cannot be recovered, often through cryptographic wiping or secure override. The privacy officer enforces compliance, while the data owner verifies the business no longer needs the data. Failure here has cost companies millions in fines. And on the exam, if you see right to erasure or secure disposal, the lifecycle stage is deletion. Every lifecycle stage ties to professional roles. The data owner sets purpose. The data steward maintains quality. Annotators provide labels. Machine learning engineers enable training. And the privacy officer ensures compliance at every stage. In real world projects, success depends on the division of responsibilities. On the exam, expect scenario-based questions where you must match a responsibility, like enforcing encryption, to the correct role. In this case, the privacy officer. Here we see the full data lifecycle represented as a pipeline. Each stage flows into the next, from collection all the way through secure deletion. Beneath every stage, you'll notice the primary roles responsible. At collection, the data owner defines purpose, while the privacy officer ensures legal consent. In storage, the data steward safeguards structure and integrity, while the privacy officer enforces encryption and access control. Labeling requires an annotator guided by the data steward to ensure consistency and reduces bias. During pre-processing, the machine learning engineer prepares data for modeling, with the data steward checking for quality and fairness. In training, the machine learning engineer runs learning processes, while the data owner verifies alignment with business goals. In archival, uh, it's handled by the data steward, ensuring retention and organization, while the privacy officer checks compliance with regulations. And finally, at deletion, the privacy officer mandates secure erasure, and the data owner confirms data is no longer required. Notice the shield running across the entire pipeline. That represents governance and compliance. It reminds us that privacy and oversight are not optional. They span across single stage. On the exam, you may see a question asking which role is responsible at a specific stage. The diagram should help you anchor those responsibilities in your memory. Here are the key takeaways. We've discussed data flows through 7 lifecycle stages, and each stage has technical plus governance responsibilities, right? And there's roles that ensure quality, ethics, and compliance. And the machine learning engineer is responsible for pre-processes and trains models. And mishandling at any stage risks trust and legal exposure. This is the end of the lesson, and I look forward to seeing you in the next